What does the future hold for quantum computing and artificial intelligence? These are the questions that have been stirring up quite the conversations in the tech world. Just last year, I penned down an article on the European Quantum Industry Consortium, or QUIC for short, and their ambitious Quantum Strategic Industry Roadmap. The progress since then has been noteworthy. To get an update, I reached out to Laure Lebars, the president of QUIC and a research project director at SAP. Lebars, a recent guest on the SAP podcast, The Future of ERP, discussed the second quantum revolution and its potential benefits to a wide array of industries. Quantum computing, a blend of quantum physics and computer science, is based on the principles of superposition and entanglement, which are the cornerstones of qubits. Unlike classical computing bits that can represent only 0 or 1, qubits can represent both states at the same time, allowing for true parallelism in quantum systems. Lebars highlighted the usefulness of quantum's unique ability to rapidly identify the best solutions through the analysis of massive volumes of heterogeneous data in optimization problems such as route planning, supplier management, and financial portfolio management. In the face of such massive data, classical computers are overwhelmed by exponential calculations. AI and machine learning algorithms are ideal candidates for quantum processing. Despite her optimism about the future of quantum computing, Lebars did caution that there are several hurdles to overcome. She anticipates the development of a general-purpose quantum advantage machine by 2030, assuming that quantum hardware, middleware, and software continue to evolve at a significant pace. To achieve this, QUIC is focusing on standardization, governance principles, intellectual property protection for quantum technologies, and industry-wide expert education and skill development. QUIC has also established an international council to collaborate with quantum peer organizations in North America and Japan to foster global industry growth. While the details of the use cases being developed for the next iteration of the QUIC Strategic Industry Roadmap are exclusive to members, Lebars did share some of the latest findings. Like any emerging technology, the promise of quantum computing is constrained by the limited number of hardware and other suppliers across the industry value chain. This encompasses cryogenic electronics, microcontrollers, high-end lasers, and superconducting cabling. Despite recent headlines praising hardware announcements for quantum computing, these machines need much more power for widespread commercial adoption. Currently, members of QUIC are identifying the challenges and sharing information to build a practical on-ramp to market expansion. For instance, according to Lebars, these early quantum computers lack the necessary qubits for processing power and are not stable enough. She stressed that as quantum hardware progresses, industry and academia need to develop new interdisciplinary education programs to combine quantum knowledge with domain experts from industrial end users. Click on like and subscribe to recommend our channel. But if you're keen to know when we release more videos, don't forget to click on that bell too. Can you imagine completing an array of complex tasks in a single step? That is the potential power of quantum computing and the root of the growing buzz surrounding its ability to tackle formidable challenges such as healthcare and climate change. For instance, consider the intricate task of climate modeling. Quantum simulations might be the optimal solution for concurrently predicting weather events based on millions of variables from the past, present, and future. Now, imagine this power in the hands of researchers studying drugs, chemicals, and various materials. They could construct models of molecular behavior using quantum simulation, scrutinizing interactions and other anomalies to test prototypes swiftly and iteratively. Now, let's shift gears and compare this to classical computing. As pointed out by Lebars, quantum computers are a different way of programming. They aren't necessarily faster than classical processing. However, they do offer significantly higher efficiencies for certain optimization algorithms. For example, the capacity to simulate climate change models simultaneously and with high granularity across millions of industry variables influencing CO2 emissions could lead to superior long-term predictions to guide sustainable strategies. Yet amidst this whirlwind of excitement surrounding technological advancements like quantum computing, Lebars offers some grounding reminders. She advises organizations to prioritize use cases for quantum computing that are currently unattainable with classical computing and balance potential benefits against unforeseen repercussions. Quantum computing, she notes, is not a cure-all. It won't entirely replace traditional computers. Certain use cases will still require classical computers, while others will be better served by quantum computing. To interact with the quantum computer, we'll need an interface, ensuring that the benefits are not offset by the potential of doubling the amount of time. Ultimately, we will need hybrid architectures and a quantum processing unit nestled next to your computer's CPU and graphics processor. As we stand on the brink of the second quantum revolution, the winner of the industry race remains unknown. Still, as we approach the year 2030, leaders are gearing up for this revolutionary shift. As Labarre said, what was a scientific fantasy even 5 years ago is becoming more real and tangible. Quantum computing has a market and an industry, and it has enormous potential. In summary, the potential of quantum computing is vast, from climate modeling to drug research, and while it won't replace classical computing, it offers a new and efficient way of processing. However, it's crucial to balance the potential benefits and understand that we are still in the early stages of this exciting new technology revolution. If you want to keep up to date and get notified when we release new videos, click on like and subscribe. This helps us keep the channel going and lets us know that you're enjoying our content.